us see the topic mechanical properties in solids. So basically here this is the first chapter we have to study. तो इस चैप्टर के अंदर हमको ये देखना है कि सॉलिड के जो प्रॉपर्टीज है तो वो हमको देखने हैं अच्छी तरह से, जिसमें हम देखते हैं कि जैसे कि हम जानते हैं देर आर थ्री solid types of material, states of matter, that is solids, liquids and gases. So here the first is the solid. We have to discuss about the solid in this chapter actually. So we know that the solids in the solids, the atoms and molecules are at their definite positions and they are in equilibrium at those states. And when the external force is applied on the bodies, then they are displaced from their equilibrium positions. And at the same time, internal elastic restoring forces are set up in the bodies, which tries to restore the equilibrium position of the atoms. तो इसका मतलब यही है कि जो एटम्स को जैसे ही हम इक्विलिब्रियम पोजीशन से डिस्टर्ब करते हैं तो वो क्या होता है कि वो अपने इक्विलिब्रियम पोजीशन से तो हट जाते हैं, लेकिन एट द सेम टाइम एक रिस्टोरिंग फोर्स उनके बीच में काम करता है जो कि उनको फिर से उसी पोजीशन पे लेके आने के लिए ट्राई करता है। ये हम ये समझ सकते हैं आराम से। और ये देखा जाता है कि अप्लाइड फोर्स जो है वो एग्जैक्ट इंटरनल इलास्टिक रिस्टोरिंग फोर्स के बराबर हुआ करता है, उसको ही हम डिफॉर्मिंग फोर्स कहते हैं। ये बात याद रखो ठीक से। अभी हम नेक्स्ट स्लाइड में जाएंगे, व्हाट इज इलास्टिसिटी एंड व्हाट इज प्लास्टिसिटी. So we can say that the elasticity is a property of the material which are like rubber or they are quartz or like this. And what is plasticity? Its examples are putty, plasticine and thick mud, like that. So basically elasticity is the property due to which the body gets deformed when the deforming force is applied on it, and again regains its original shape and size whenever the deforming force is removed from it. But plasticity, on the other hand, is the property due to which the substance gets deformed when the deforming force is applied on it, but doesn't regain the original shape and size even if the deforming force is removed from it. So this is called as the plasticity. Okay, now we'll see what is the stress and strain. Basically, the stress is defined as the deforming force per unit area. Actually, it is defined as the internal restoring force per unit area. But it can, since we know that the internal restoring force is exactly same as the deforming force, so we can say that the deforming force per unit area can also be defined as stress, and its unit is Newton per meter square, and its dimensions are L-1, M1 and T-2. We can see it in the diagram. So the cross-sectional area is going to be the area at which the body is perpendicular to it, and on the other hand the strain is nothing but the change in dimensions upon original dimensions. For example, change in length upon original length, or change in volume upon change original volume, or change in shape upon original shape. This is the definition of the strain actually. It is a measure of deformation in the body. How much deformation is produced in the body, that is obtained by, or that is described by the concept of strain. Let us strain is a dimensionless quantity, as its definition suggests. It is a ratio of two similar quantities, and that's why it's dimensionless and unitless also. Let us see the next topic, that is about the difference between stress and strain. The first thing is that internal restoring force per unit area is called stress, but the change in dimension per unit original dimension is called strain. SI unit of stress is Newton per meter square, whereas strain is unitless. Stress has the dimensions L-1, M1, T-2, whereas strain is dimensionless. And basically stress is the cause and strain is its effect. Let us move to the next topic, that is about the relationship between the stress and strain, which is expressed by Hooke's law, which tells us that within elastic limit, stress is directly proportional to the strain. As we can see from this graph, that if we draw the graph between stress and strain, then it will be a straight line showing that they are proportional to each other. And the constant of proportionality between stress and strain will be denoted by M, so that we can say that the stress upon strain is a constant, and this constant is also called as the modulus of elasticity, which measures the elasticity of the body. The maximum value of stress up to which the stress is directly proportional to the strain is called as elastic limit. Okay, elastic limit is the point on the stress strain curve up to which they are proportional to each other. So the next topic is about the tensile stress or compressive stress, we can say. Whenever the body is extended, then a tensile stress is produced, which is defined as force per unit area. Whenever the elongation is produced in the wire, that is the example of tensile stress. Compressive stress is nothing but whenever the wire is compressed or any substance is compressed, then the force per unit area in that case is also called as the compressive stress. The length of this, in this case of the rod, decreases. SI units and dimensions are same as the of the stress basically. Next topic is about, you can say, tensile strain, or you can say linear strain, which is defined as the change in length per unit original length of the wire. तो ये इस तरह से हम डिफाइन कर सकते हैं, the change in length upon original length, which is called as the tensile strain. Its formula is delta L upon L. Then again, the tensile strain is produces due to the tensile deforming force. So मतलब whenever the force acting on the body is along the length of the wire, along the length, then that force produces the tensile strain. Okay, you can see the next thing, that is our daily life examples. So whenever a truck is traveling along a bridge, the bridge undergoes tensile or compressive strain in this way. Even the ropes are supported for a bridge. That is example of the tensile stress and tensile strain. Even the lift or elevator or escalator is also an example of the tensile strain and tensile stress. Or even the crane is also an example of this stress and strain. Next thing is about the expression of Young's modulus. So we know that longitudinal stress is defined as force upon area. If m is the mass applied on the body, and suppose that the r is the radius of the cross section of the wire, then we can say that this mg upon pi r square will be the formula for longitudinal stress. Longitudinal strain, on the other hand, is defined as the change in length upon original length. And we know that by Hooke's law, the longitudinal stress is proportional to the longitudinal strain. The constant of proportionality in this is called as Y, which is called as Young's modulus. And therefore, the Young's modulus is defined as longitudinal stress upon longitudinal strain. And here, this Young's modulus comes out to be force per unit area divided by small l upon capital L, which can also be written as mgl upon pi r square small l. And this is the expression for Young's modulus, whose SI unit is same as that of the stress and dimensions also the same as that of the stress. Here we can understand that Young's modulus of elasticity is related to the change in length of the object. You know, for example, meter wire or rod, beam are, whenever they are applied deforming force along its length, then that stress produced or the modulus of elasticity related to that will be called as the Young's modulus. Here, one important useful characterization of an object subjected to compression or tension. तो जब भी कोई भी ऑब्जेक्ट टेंशन या कंप्रेशन के साथ सब्जेक्टेड होता है, तो उस समय जो स्ट्रेस या स्ट्रेन प्रोड्यूस होता है उसके साथ रिलेटेड मॉडल्स ऑफ इलास्टिसिटी मतलब ही यंग्स मॉडुलस कहलाता है. Actually, the value of y depends on the nature of material. If the material has a large value of y, that means it resists the elastic deformation and large stress is required to produce a small strain, and it measures the elastic stiffness of a body. Next is about the Poisson's ratio, that is denoted by sigma. We know that whenever the force is applied on the free end of the wire, the length of the wire increases. At the same time, its diameter decreases. On the other hand, if equal and opposite force is applied on the wire, the length of the wire is decreased and at the same time diameter of the wire increases. तो ये हम देख सकते हैं कि whenever the wire is extended longitudinally, it have a contraction in laterally, and whenever the wire is contracted longitudinally, it has a contraction longitudinally. तो ये जो बात है यही पॉइजन्स रेशियो के साथ रिलेटेड है. अगर हम कंसिडर करते हैं पॉइजन्स रेशियो का एक्सप्रेशन, तो उसके लिए हमको ये करना पड़ेगा लीनियर स्ट्रेन, जो कि जैसा कि हम जानते हैं द लीनियर स्ट्रेन इज डिफाइंड एज द change in length upon original length, that is small l upon capital L. Lateral strain can be defined as the change in diameter upon original diameter, that is small d upon capital D. And whenever there is a lateral strain in a direction perpendicular to the applied force, तो मतलब इस एक longitudinal direction में अगर longitudinal strain होता है तो पर उसके perpendicular direction में lateral strain produce होता है. Or within elastic limit we can say the lateral strain and longitudinal strain are just proportional to each other, and the ratio of these two is called as Poisson's ratio, which is denoted by sigma. So sigma will actually be the ratio of lateral strain upon longitudinal strain, which is small d by capital D divided by small l upon capital L, which is going to be d capital L upon capital D small l. And this is a unitless quantity, and as well as it is a dimensionless also. Okay. The next thing is about volume stress, or it is also called as a hydraulic stress. What is volume stress? Whenever the deforming force produces a change in volume of a body, then the stress associated with it is called as the volume stress. Here we can see in the diagram, the block is compressed in from all the sides, and that's why it's called as a volume stress, which is defined as the force per unit area, which is actually equal to the change in pressure, that is dP. It can also be expansive or compressive also, and it has the same units as that of the stress, that is Newton per meter square, and dimensions are also as expected L minus 1, M1, T minus 2. The next is about the volume strain. What is volume strain? The deforming force, whenever the deforming force produces the change in volume of the body, then the strain produced in it is called as volume strain, which is defined as the change in volume upon original volume, that is delta V upon capital V. And here it is a dimensionless quantity once again. The next is about the bulk modulus of a body, expression for bulk modulus, which is the ratio of volume stress to the volume strain. So in order to find out the expression for bulk modulus, we'll have to find out the expression for volume stress and volume strain and have to divide these two. So volume stress, as we know, it is to be equal to dP, and volume strain is always equal to dV by V. And by Hooke's law, volume stress is proportional to the volume strain. So volume stress is going to be some constant K into volume strain, so that the constant of proportionality K happens to be the ratio of volume stress to the volume strain. And this ratio actually is called as bulk modulus, and it is equal to dP upon dV by V, which can also be written as V into dP by dV. And this is going to be the expression for volume strain, bulk modulus. Next is about bulk modulus and compressibility. Basically, compressibility is defined as the reciprocal of bulk modulus. 1 upon bulk modulus is the formula for compressibility, and whose formula can also be derived by just inverting the formula for bulk modulus, and its dimensions and units can also be seen to be reverse of that of the bulk modulus. Next is about shearing stress, which is defined as the tangential force applied per unit area. So whenever the tangential force is applied on the body, it produces the change in volume only, change in shape only, not in the volume or length, but it produces the change in shape only, and its SI unit and dimensions are exactly same as that of the stress. Shearing strain is defined as the change in shape upon original shape, but shape cannot be measured, and that's why what we do is we consider the relative displacement of any layer and compare it with the distance of that layer from the fixed layer.